Good morning. Today's lesson we're talking about the Pythagorean theorem and special right triangles. So let's refresh your memory on what the Pythagorean theorem is. I don't know if you've all seen this in Algebra 1 or not, but the Pythagorean theorem is when you have a right triangle, it says that the sum of the squares of the lengths of the legs are equal to the square of the length of the hypotenuse. So a reminder that the hypotenuse is the side that is across from the right angle, or it's always the longest side, and that the legs are the two sides that touch the right angle, and together they connect and form that 90 degrees, and those are going to be the two shorter sides. So the Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. So when we have a right triangle and all three sides are whole numbers, we call that a Pythagorean triple. So a Pythagorean triple is three whole numbers, not rounded, they have to be perfectly whole, that satisfy the Pythagorean theorem. Okay, so let's do some examples. So our first example is find the length of the hypotenuse of triangle ABC. Do the lengths of triangle ABC form a Pythagorean triple? So basically, I want to make sure all three are whole numbers. We have two legs that are whole numbers, 20 and 21, and so we want to see if that c squared is going to be a whole number. Okay, so here we're going to call that side C. So I know 20 squared plus 21 squared equals c squared. So I'm going to get 400 plus, let me get out my calculator here. 400 plus 441 equals c squared. And then we're going to get 841 equals c squared. We're going to take the square root of both sides to get just c. And when I take the square root of 841, I get 29. So that's my third side. And so my answer would be yes. 20, 21, and 29 form a Pythagorean triple. Okay, and that's because they are whole numbers. So if I got 29.5 is C, then no, it would not form a Pythagorean triple. Both of my dogs are sitting next to me on the couch, so if you hear them making, dog noises, I apologize. All right, next example. We are also finding the value of the side of a triangle. So here we have x. Leave your answer in simplest radical form. So for this one, I'm going to go ahead and figure out if this is a leg or the hypotenuse. So it's a leg. So I have 8 squared plus x squared equals 20 squared. So 64 plus x squared equals 400. So then I'm going to subtract 64 from both sides. So then I get x squared equals 336. Take the square root of both sides. Okay. And when I plug the square root of 336 into my calculator, I do not get a whole number. So this is where we do the simplest radical form. Okay, so let's practice simplest radical form. So for simplest radical form, I'm going to look at my perfect square values. So remember, perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared, okay? And so on and so forth. I mean, they keep going. But we're just going to look and we're going to see, do any of these go into 336? And so when I look at these, I'm going to divide 336 and I say, 4 goes into 336. And you can try these on your calculator, right? Trial and error. So 336 divided by 4, 336 divided by 9, 336 divided by 16. 16 works too. Okay, and then you keep going. Okay, and you try and find the biggest one that goes into 336. In this case, it is 16. So if I rewrite 336, 336 is the same thing as 16 times 21. Then I can say, oh, that's the square root of 16 times the square root of 21. And the square root of 16, because it's a perfect square, is 4. So now I have 4 times the square root of 21. And there is nothing on this list, 4, 9, 16, 21, that goes into 21. So 21 is not divisible by any of those numbers. That's how I know I am done, and it's in simplest radical form. Okay, so that would be my answer here, would be x equals 4 root 21. All right, next we have a theorem that is the converse of the Pythagorean theorem. It says if the square of the lengths of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So essentially what this says, it says if a squared plus b squared equals c squared, then it's a right triangle. Okay? And remember that c has to be the longest side. Okay? Always the longest side. So for this example, it says, is this a right triangle? So if we have this, 13 is A, 84 is B, and 85 is C, what I'm asking is, does A squared plus B squared equal C squared? And so when we're asking this question, we don't know if they're equal. So stating that they're equal from the beginning is actually incorrect. So what I'd like you to do is calculate these separately, or you can put a question mark above your equal sign, but since you're going to be typing this, we're going to calculate them separately and then see if they are equal. So first we're going to do A squared plus B squared. So I get 13 squared plus 84 squared. And then that is 169 plus 7,056. Which equals 7,225. And then separately, I'm going to calculate c squared, which is 85 squared, which equals 7,225 as well. So since they are equal, we can say, yes, it's a right triangle. My dogs are playing, so if you hear some, now they were sleeping in the beginning and now they're up playing. So anyways. Okay, next we have two theorems, and these theorems tell us whether when it's not a right triangle, so in example C we had a right triangle, but if they weren't equal, we would be able to determine if it's an acute triangle or an obtuse triangle. So theorem 8.3 basically says if that hypotenuse, C, if that hypotenuse is bigger than A squared plus B squared, my right angle has to open up further, and therefore it's going to be obtuse. In the next theorem, if C squared is less than the sum of A squared plus B squared, then that angle doesn't have to open up as much, and therefore it's not going to be a right angle. It's going to be smaller, so we'll have an acute triangle. So let's look at this. Once again, remember that C is always the longest side. Okay, so once again, we're going to calculate A squared plus B squared separately from C squared. So classify the triangle whose side lengths are 6, 11, and 14 as acute, obtuse, or right. So let's calculate C squared. So C has to be the longest side, so C is 14. So 14 squared equals 196. And then A squared plus B squared is going to be 6 squared plus 11 squared. So 36 plus 121, which gives me 157. So here I have that C squared is greater than A squared plus B squared. And so that scenario is going to fit this right here. So my triangle is obtuse. Okay? So go ahead, practice using simplest radical form, and go ahead and start your homework.